Alright, in this video we're going to talk about polygons and the angles that are related to them. Interior angles and exterior angles. So again, a polygon is any shape that is connected, right? So things we're used to seeing are triangles, squares, rectangles, pentagons, hexagons, octagons. These are all different types of polynomials. Polygons. All right, so when we talk about polygons, we're going to talk first about interior angles. Those are the angles inside the polygon. Now, one concept we need to talk about is what's called a diagonal. So a diagonal would connect a vertice to an opposite vertice across the polygon. So B and A would not be a diagonal because it doesn't go across. B to E would be a diagonal. B to D would be a diagonal. D to A would be a diagonal, and E to C would also be a diagonal. So there's lots of different diagonals we can use. Now, what happens is when a diagonal is created, a triangle is also created. So if you notice here from B to D, we create a triangle. From B to E, we create a triangle. So what we want to do in theory is create triangles in here, and we know that a triangle is 180 degrees. So we have 180 plus 180 plus 180. So if we add that up, we would get our interior angle total. Now, here's the shortcut, is that how many triangles do we have here? We have 3. How many sides do we have here? 1, 2, 3, 4, 5. 5 sides. So 5 sides give us 3 triangles, and 3 triangles times 180 would give us our answer. So we come up with this formula down here. N is the number of sides, minus 2, always minus 2, times 180. So in this case, we have 5 minus 2 gives us 3 triangles. So this n minus 2 would tell us how many triangles are created by drawing diagonals, times the degrees of the triangle. So that's how you determine how big, how many angles, how many degrees are in a polygon. Okay, so here, how many degrees are in an octagon? Well, how many sides are there? So we take our formula here. N is the number of sides, and we have 8. So we do 8 minus 2, which is 6. 6 times 180 would give us 1,080 degrees. And that's it. That's all you do. You plug the number of sides in. You can even type that in the calculator as you see it, and it would give you 1,080. So this is very, very easy to do. All right, next. We want to take the same formula, but now we want to find n. We tried to find the degrees, but now what if we know the degrees, but we want to find the shape? So say I give you a shape and say it's 900 degrees, right? Well, how many sides is that? Okay, so in this case, we have our formula, and 900 degrees is our degree angle. So what we're first going to do is divide by 180. So the degrees divided by 180, right, would give us 5, and you see that step right here. Okay, and then we just add 2 to that, which would give us 7. So 7 sides is 900 degrees. Now go back to the example I just gave you prior, right? If we have 7 sides, that's 900. And if I add a side, I'm adding 180 degrees. So every time you add a side, we're adding 180. So watch, a triangle is 180 degrees, right? Okay, if I add a side, I can make a square. Well, how much is a square? A square is 360 degrees. I just added 180. If I want a pentagon, what do? I add 180, and that would give us 540. So if you're ever unsure, another way to do it is every time you add a side, we add 180 degrees to the angle measures of that polygon. Okay. All right. So here's an example where now we want to find an unknown angle. So this is where we're going to add up everything we have, and it's going to equal to something, but one part is missing. So in the past, we've seen problems like this where we'd have a triangle, and we'd have 100, and we'd have 40, and we want to find x, right? And we know that a triangle adds up to 180 degrees. So we would do x plus 40 plus 100 is equal to 180 and go ahead and solve. And there are some other variations of that get more complicated with more equation type angles or more number-based angles. So that's what we're doing here. So in this case, we have 4 angles, and all of them have to add up to a certain degree amount. And if you don't know, a four-sided shape, a quadrilateral, adds up to 360 degrees, we can use our formula, right? So how many sides do we have? We have 4 sides minus 2 times 180, right? Well, what is 2 times 180? That is 360. So if you weren't sure, we go back to the formula that we just talked about. So now we have this number because that's the number we needed. We know that x plus 108 plus 121 plus 59 is going to equal to something. And if you don't know what that something is, we need to use the formula that we just talked about, the interior angle formula. So we combine like terms, we subtract, and in this case, we would be done. Okay? So this is a type of problem that we've seen over and over again throughout the year. Now we're just dealing with interior angles of various polygons. All right, now let's talk about this. The sums of interior angles of a quadrilateral are 360. We just went through that, okay? All right, now, what about exterior angles? Well, let's talk about this for a second. If I had an equilateral triangle, and I drew exterior angles. So if you recall the exterior angle lesson we've done in the past. So if this is an equilateral, these are all 60. Okay? So that means that these angles out here, the exterior, have to be 120 degrees. In this case, because they would need to form a linear pair. Okay? So if we add up 120, 120, 120, the total of the exterior angles is going to equal to 360 degrees. All right, if I have a square, all of these are 90. So if I were to do exterior angles here, 90 plus 90 plus 90 plus 90 is equal to 360. So the exterior angles here are going to equal to 360. So the exterior angles always add up to 360 degrees. All right, so let's take a look at this problem. How many exterior angles do we have? We have 1, 2, 3, and 4. So if we add up those 4 angles, they need to add up to 360. Why 360? Because the exterior angles add up to 360 degrees. All right, so we combine like terms, we get 3x, we combine the values of just the numbers, we get 156. Subtract, divide by 3, we get x equaling to 68. Now, we do have to pay attention in directions because it just says find x. If it did ask us to find all the exterior angles itself, we would have to plug it in. So this one, if we did have to plug it in, would be 68. Now remember, the directions don't tell us, but if it did, this is how you would do it. So 68 here, and then this would be 2 times 68, which would be 136, I believe. Okay? So that's interior and exterior angles of polygons.